May I kindly request Dr. K. Srinivas Rao, Professor, Department of Mathematics, Kanchipuram University, Tamil Nadu, India, to kindly chair this session. Kindly, please, sir. May I now invite Dr. J.B. Torangati, Assistant Professor, Karnataka College, Dharwad, Karnataka, to kindly present the paper. Please, sir.
Good morning. Myself, Dr. J.B. Thornagatti, working as Assistant Professor in the Department of Mathematics, Karnataka College, Dharwad. My presentation topic is on delta pre-regular star open sets. Abstract. The purpose of this paper is to introduce a new class of sets called delta pre-regular star open sets in topological spaces. Some properties and characterization of delta pre-regular star open sets are investigated. Moreover, some new decompositions of completely continuity are obtained. Introduction. The idea of delta open sets on a topological spaces was introduced by Velikow in 1968 as a strong form of open sets. In 1993, Rai Chaudhuri and Mukherjee introduced the concept of delta free open sets by using delta open sets. Recently, Jayanti and others introduced the concept of pre-regular open sets as a generalization of pre-closed open sets. In this paper, a new class of sets called delta pre-regular star open sets is introduced and studied. By using delta pre-regular star open sets, new decompositions of regular open sets are obtained. Preliminaries. Definition: a subset A of a topological space X is called delta pre-closed, respectively E star closed, delta semi-closed, and A closed if closure of delta interior of A is subset of A, respectively closure of interior of delta closure of A is subset of A, interior of delta closure of A is subset of A, and interior of closure of delta interior of A is subset of A. Next definition: a subset A of a topological space X is called delta closed if A equals to delta closure of A, where delta closure of A is the collection of members in X such that intersection of the interior of closure of U and A is non-empty, where U is an open set containing X. Delta pre-regular star open sets. Definition: a subset N of a space X2 is said to be delta pre-regular star open if N equals to delta pre-interior of E star closure of N. The complement of a delta pre-regular star open set is called a delta pre-regular star closure set. Clearly, N is delta pre-regular star closed if and only if N equals to delta pre-closure of E star interior of N. The collection of all delta pre-regular E star open, respectively delta pre-regular star closed sets of X2 will be denoted by delta PR star O of X, respectively delta PR star C of X. The following theorem gives the properties of delta pre-regular E open sets. Let X2 be a topological space and M and N be subsets of X, then the following statements hold. If M is a subset of N, then delta pre-interior of E star closure of M is a subset of delta pre-interior of E star closure of N. If M is a delta pre-open set in X, then M is a subset of delta pre-interior of E star closure of M. If M is E star closed set in X, then delta pre-closure of E star interior of M is a subset of M. Delta pre-interior of E star closure of N is always a delta pre-regular E star open set. If M is A star closed set in X, then delta pre-interior of M is a delta pre-regular star open set. And these two theorems give the correct characterization of delta pre-regular star open sets. Theorem 1.3. Let X2 be a topological space and N be a subset of X. Then N is delta pre-regular E star open if and only if N is E star closed and delta pre-open. Next theorem. Let X2 be a topological space and M be a subset of X when the following statements are equivalent. M is delta pre-regular E star open. M equals to E star closure of M intersection interior of delta closure of M. M equals to delta pre-interior of M union interior of closure of delta interior of M. And fourth condition, M equal to M intersection closure of delta interior of M union interior of closure of delta interior of M. Every regular open set is regular delta pre-open. To find the characterization of regular open sets, we need definition 1.6. A subset N of a space X2 is called Q star set if interior of delta closure of N is a subset of closure of delta interior of N, where N is a subset of X. For a subset M of a space X, the following statements are equivalent. M is regular open, M is delta pre-regular star open, and a Q star set, M is A open and E star closed. A space X2 is called extremely delta pre-disconnected if the delta pre-closure of every delta pre-open subset of X is delta pre-open. For an extremely delta pre-disconnected space X2, the following statements are equivalent for any set M of X. M is delta pre-regular star open, M is delta pre-regular star closed, M is delta pre-close open, M is E star close. Here delta pre-close open means it is both delta pre-open and delta pre-closed. E star close open means it is both E star open and E star close set. Definition is space X2 has the property Q star if interior of delta closure of N equal to closure of delta interior of N. By make use of this definition, we shall find the following result. Let X2 be a topological space with the property Q star. Then for any set M of X, the following statements are equivalent. M is delta pre-regular star open, M is delta pre-regular star closed, M is regular open, M is regular closed. Decomposition of completely continuity. A function f from a topological space X2 to a topological space Y sigma is called delta pre-regular star continuous if the inverse image of every open set of Y is delta pre-regular star open in X. Next definition, a function f from X2 to Y sigma is called Q star continuous if the inverse image of every open set of Y is Q star set in X. For a function f from X to Y, the following statements are equivalent. F is completely continuous. F is delta pre-regular star continuous and delta continuous. F is delta pre-regular star continuous and A continuous. F is delta pre-regular star continuous and delta semi-continuous. F is delta pre-regular star continuous and Q star continuous. These are the some equivalent statements, and this gives the decompositions of completely continuous function. These are the some references which I have used to prepare this paper. Thank you. Thank you one and all.
Now the next presenter. May I request Ms. G. Menaka, Assistant Professor, Sri Shakti Institute of Engineering and Technology, Coimbatore, Tamil Nadu, to present the paper. Madam, kindly please.
Hello, good morning all. I am Menaka, Assistant Professor, Sri Shakti Institute of Engineering and Technology in Coimbatore. Now I am going to explain optimization of fuzzy transshipment problem using generalized octagonal fuzzy numbers. That is, we introduced octagonal fuzzy numbers using solve optimal solution of fuzzy transshipment problem. We solved balanced and unbalanced fuzzy transshipment problem by Modi method. Then we go to first introduced definition of fuzzy set. Let a capital X be a non-empty fuzzy set. So the value, it's called membership function. U A of X is called membership function that values between 0 and 1. Then fuzzy numbers means generalization of regular real numbers. Then we go to next generalized hexagonal fuzzy numbers. That means 6 real numbers in membership function. This is membership function. This is hexagonal fuzzy numbers formula. Then next we go to ranking of generalized hexagonal fuzzy numbers. Have 6 real values and its membership function. Then R of A not equal to, this is called ranking of generalized hexagonal fuzzy numbers. Then we go to generalized octagonal fuzzy numbers. It's called 8 real numbers and its membership function. This is called formula. This is called octagonal fuzzy numbers formula. Then next going to ranking of generalized octagonal fuzzy numbers. These are all R of A naught equal to 2A1 plus 3A2 plus 4A3 plus 5A4 plus 5A5 plus 4A6 plus 3A7 and 2A8 divided by 28, 7W by 28. This is ranking of generalized octagonal fuzzy numbers formula. First of all, we're going to explain what is transportation problem. Transportation problem is one source to the goods or containers one moves to one source to another source. But transshipment problem is the same moves to one source to another source, but the intermediate destination, that is called transshipment problem. We have to find balanced generalized octagonal fuzzy transshipment problem. Now we're going to find optimal solution and initial basic feasible solution. These are all octagonal fuzzy numbers in transshipment problem. This is the transshipment table. Then this is demand and supply are equal. That is called balanced transshipment problem. So we go to find octagonal fuzzy numbers using ranking method, convert to crisp value. That is, first you have take the first A1 value. So convert it to the crisp value is 1.12. Then similarly we are going to, for all values, find it the crisp value. And this is our transshipment problem. So now we're going to apply BEM method, that is the Burger's approximation method, to find the initial basic feasible solution. That value is 0.9107. Then we go to apply find optimal solution and applying Modi method. So we go to apply the Modi method and the final answer is 0.9107. Then next we go to find unbalanced generalized octagonal fuzzy transshipment problem. What is unbalanced? Unbalanced means our supply and demand values are not equal. That is called unbalanced transshipment problem. We have to convert balanced transshipment problem. So after that you have find optimal solution. Then for these are all octagonal fuzzy numbers. This is octagonal fuzzy numbers transshipment problem table, but that is demand not equal to supply. So we have to convert demand equal to supply, including dummy variable in this table. So we consider balanced transshipment problem. After that, saying and the ranking, applying the ranking method, octagonal fuzzy numbers converted to the crisp value. The value is 1.12. Similarly, they find all the values and the table is transshipment problem. Now I am going to apply BAM method, that is Borger's approximation method, to find the initial basic feasible solution. The answer is 1.4. Then next we go to find optimal solution applying Moody method. Then the answer is 1.4. Now we going to comparison table. And, they are find hexagonal fuzzy numbers. Balanced transshipment problem is 1.16. An unbalanced transshipment problem value is 2.6. But now I am going to try the octagonal fuzzy numbers. Balanced transshipment problem is 0.9107. An unbalanced transshipment problem is 1.4. This is comparison table for hexagonal fuzzy numbers and octagonal fuzzy numbers. The final conclusion is the balanced and unbalanced transshipment problem proves to minimum cost of transportation. It is conclusion. Okay. These are all reference. Thank you.
Now we request Ms. T. Vasugi, guest faculty, Mother Teresa Women's University, Chennai, and Dr. V. Kamal Nasir, Assistant Professor, the New College, Chennai, and Dr. N. Jansi Rani, Assistant Professor, Queen Mary's College, Chennai, Tamil Nadu, to present the paper. Kindly, please.
Hello everyone, this is Vasugi, guest faculty, Department of Mathematics, Mother Teresa Women's University, Chennai. This paper is co-authored by V. Kamal Nasir, Associate Professor, and N. Jansirani, Associate Professor. My paper ID is 1132. My topic is on convergence, compactness, and covering properties of diminishing fuzzy sets. Structure of the work goes as follows: abstract, introduction, main results, application, conclusion, and future work. In this paper, the idea of the diminishing cells infinite array is generalized using the concept of fuzzy sets named as diminishing fuzzy sets (DFS). The basic definitions of convergence, sequence, compactness, and covering properties of fuzzy sets are investigated, and the basic theorems for compactness of fuzzy topology are also studied. Furthermore, the above mentioned basic definitions and basic theorems are extended to the diminishing fuzzy sets, and compactness of diminishing fuzzy sets is obtained via covering properties and finite intersection property, and a brief introduction of fuzzy subset theory is given in order to extend it to the diminishing fuzzy sets to obtain some fruitful results in future. Keywords are convergent, diminishing fuzzy subsets, finite intersection property, open cover, and topology. Fuzzy set theory was introduced by Elizadeh in 1965 with the grades of membership assigned in the interval 0, 1. Fuzzy set theory handles the vagueness in the real life applications well, which is expanded drastically in the field of mathematics that involves topology, control theory, data analysis, and artificial intelligence, etc. In 1968, C.L. Chang introduced the fuzzy topology with the help of fuzzy sets theory introduced by Elizadeh. In 2011, N. Jansirani and V. Rajkumar Dare introduced the diminishing cells infinite array using basic automata theory denoted by DR, and studied some of their combinatorial properties, topological properties, and a complete metric in the DR array. Now we'll be seeing diminishing fuzzy sets DFS. We define a function mu dr from R to 2 closed interval 0, 1 by mu dr of x, y, which is equal to 1 when x is equal to y, 1 by n par k when x is not equal to y, and k is equal to modulus of x minus y, that is the distance between the points x and y, where x and y belongs to the real line and n belongs to the set of all natural numbers, and n must be greater or equal to 2. We are claiming that this is a fuzzy set by the following by satisfying the following properties. The function mu dr is normal because the set mu dr is normal because when x is equal to y, it attains its maximum value as 1. Mu dr is a fuzzy convex for any x1, x2 belongs to the plane R2 and lambda belongs to the closed interval 0, 1. We will be seeing this by an example. When we take x1 is equal to 4, 5, x2 is equal to 8, 7 and lambda is equal to half, then we will be arriving at mu dr of lambda x1 plus 1 minus lambda into x2, which is equal to 1. By the previous by the above definition, we know that when x is equal to y, it is 1. And minimum of mu dr of x1 and comma mu dr of x2, which is equal to minimum of mu dr of 4, 5, mu dr of 8, 7, which is equal to 1 by 2 per k. That means which is nothing but which implies that 1 is greater or equal to 1 by 2 per k irrespective of the value of k. This proves that mu dr of lambda x1 plus 1 minus lambda x2, which is greater or equal to minimum of mu dr of x1 comma mu dr of x2, that is it is a fuzzy convex. Next thing is this function is upper semi continuous when x is equal to y, because when x is equal to y, it times it gets maximum value as 1 in its neighborhood. And if we consider the subsequence 1 by 2 per k of the sequence 1 by 2 per k, which converges to the point 0 as k tends to infinity, which is again contained in the same interval, the closed interval 0, 1. So, which implies that the closure of the fuzzy diminishing fuzzy state is compact. And next we will be seeing the fuzzy topology for diminishing fuzzy sets. Suppose we consider the universal sage xr as the coordinates x1 comma y1 with the membership grades half, x2 comma y2 with the membership grades 1 by 2 square, and x3 comma 1 y3 with the membership grades 1 by 2 cube. Then the topology of mu dr is mu dr of x comma y, which is equal to the empty set, the whole set 1 by 2 1 by 2 cube, the set 1 by 2, 1 by 2 square, and the set half, where dr is contained in the set of all diminishing fuzzy sets, script dr. And we will be proving this by an we claiming that the above tr is a fuzzy diminishing fuzzy topological space. The above tr is a fuzzy topology for the diminishing fuzzy sets. So, if we take any two subsets from the fuzzy from the topology, we will be arriving at as half, which is again belongs to the fuzzy topology tr. And if we try to get a union, which is also belongs to the topology tr, and we are claiming that we are saying that xr comma tr is a diminishing fuzzy topological space, and every member of this topology is called as open diminishing fuzzy set, and its complement is as closed diminishing fuzzy set. Now we are moving on to the main results, basic proportions and basic theorems for diminishing fuzzy sets. A diminishing fuzzy topological space is sequentially compact if every sequence of diminishing fuzzy sets has a convergent subsequence. If we try to find a sequence from the diminishing sequence which converges to some point, some diminishing set itself, diminishing fuzzy set itself. If we try to find the subsequence from the sequence, again it converges to the same fuzzy set, same diminishing fuzzy set. So it has that therefore every sequence of diminishing fuzzy set it has a convergent subsequence. Hence it proves that it is a sequentially compact space. Second proposition says that a diminishing fuzzy topological space is compact if every open coverage of the space has a finite subcover. If we try to find the cover of the whole space xr and if we take some subcollection from the open coverage from the open coverage, which is again covers the whole space, means then it has every open coverage of the space has a finite subcoverage. Therefore the diminishing fuzzy topological space is compact. Next is theorem 3. If a neighborhood system of each diminishing fuzzy sets in a diminishing fuzzy topological space is countable, then a diminishing fuzzy sets ARK is open if and only if each sequence of diminishing fuzzy sets which converges to a diminishing fuzzy set BR contained in the diminishing fuzzy set ARK is eventually contained in ARK, which means that we know that the diminishing fuzzy set is the sequence of diminishing fuzzy set is a decreasing sequence. So obviously it has neighborhoods, and means it implies the open set. And vice versa is also the same things. Okay, next we will be seeing the proposition for a family ARK is contained in the family of the set of all diminishing fuzzy sets of diminishing fuzzy sets as the finite intersection property if the intersection of the members of each finite family of ARK is non-empty. If we try to find the finite subfamily of the ARK, if we take the intersection of that finite intersection, we will be arriving at the answer as a non-empty. Hence, it has hence the family ARK has the finite intersection property. And theorem 5 states that a diminishing fuzzy topological space is compact if and only if each family of a closed diminishing fuzzy sets which has the finite intersection property as a non-empty intersection. So first we had to prove that compactness in the form of open coverage. Now we are proving it as a closed fuzzy sets which have each family of a closed fuzzy sets which has the finite intersection property as a non-empty intersection. Next, we will be seeing the result as a fuzzy subset can be extended to a diminishing fuzzy set through this example. K1, K2, K3, K4, K5 is the parameters, and 1 by 2, 1 by 3 square, 1 by 4, 1 by 6, 1 by 5 cube, 1 by 2 power 4 is the universal set. So K1, K2, K1 is the distance between the point chains with the distance span, and it goes as for K2 is the distance 2, K3 is distance 3, and K4 is distance 4, and K5 is distance 5. These are the applications. We can be using these applications in image compression using multi-scale decomposition as well as restoration method, and provided with an application in the area of pattern recognition. The application of diminishing cells infinite array using multi-scale decomposition based on Gaussian and Laplacian decomposition and restoration are well noticeable. The conclusion says that the basic definitions and basic theorems of covering and compactness for fuzzy topology are extended to the diminishing fuzzy sets by satisfying their properties, and fuzzy subset theory is discussed, and the basic definition of fuzzy subset is extended to diminishing fuzzy sets to obtain some fruitful result in future. My future work will be focusing on pattern recognition, image analysis, and medical imaging. These are my references. Thank you.
May I now request Mr. Arif Hussain Butt, research scholar, Jamia Millia Islamic Central University, New Delhi, to kindly present the paper. Kindly, please, sir.
Respected dignitaries, good day to all of you. I am Arif Hussain Bhatt. I am going to present my paper, which is entitled Some Generalizations of Grosvenor-Hofstadter integrals. This is the outline of my paper. Grosvenor-Hofstadter type integrals were evaluated by the use of applicable contour integrals and Cauchy's ratio theorem. In this paper, we have evaluated Grosvenor-Hofstadter type integrals and other associated integrals with suitable convergence conditions by using hypergeometric approach. Some applications of Grosvenor-Hofstadter type integrals are also obtained in the form of Weber-Anger type functions. This is introduction. The hippocampus symbol alpha p belongs to complex number is defined by alpha of p is equal to gamma of alpha plus p upon gamma of alpha. It is further equal to 1 if p is equal to 0. Alpha belongs to complex number excluding 0, and alpha into alpha plus 1, so on alpha plus n minus 1 if p is equal to n belongs to natural number. Alpha belongs to complex number excluding z0 negative, and so on, which you can see in the equation 2.1. Generalize the hypergeometric function of one variable. A natural generalization of Gaussian hypergeometric series 2f1 is accomplished by introducing any arbitrary number of numerator and denominator parameters. The resulting series is shown in equation 3.1. Here p and q are positive integers or 0, and we assume that the variables are the numerator parameters alpha 1, alpha 2, so on alpha p, and the denominator parameters beta 1, beta 2, so on beta q take on complex values, provided that beta j not equal to 0, -1, -2, j is equal to 1, 2, up to q. These are the convergence conditions of the above hypergeometric function. The above hypergeometric function converges per modulus of z less than infinity if p less or equal to q, converges per modulus of z less than 1 if p is equal to q plus 1, diverges for all z not equal to 0 if p greater than q plus 1, and so on. You can see in equation 4.1. Double hypergeometric function of Shrivastava. It was given by Shrivastava Dost, defined a generalization of competitive function by means of double hypergeometric series, which is shown in equation 5.1. We assume that delta 1 is equal to 1 plus summation j running from 1 to c delta j plus summation j running from 1 to d neta j minus summation j running from 1 to a over theta j minus summation j running from 1 to b over phi j, shown in equation 5.2. Similarly, delta 2, which is shown in equation 5.3. Here, three cases arise. The double power series in 5.1 converges for all complex values of x and y when delta 1 greater than 0 and delta 2 greater than 0. Case second, the double power series in 5.1 is convergent when delta 1 is equal to 0, delta 2 is equal to 0, modulus of x less than rho 1, modulus of y less than rho 2, where rho 1 is equal to minimum mu 1 mu 2 greater than 0 e1, comma, rho 2 is equal to minimum u1 u2 greater than 0 e2. Case third, the double power series in 5.1 would diverge except when trivially x is equal to y is equal to 0, when delta 1 less than 0 and delta 2 less than 0. Cauchy double series identities are shown in equations 6.1, 6.2, 6.3, and 6.4. Gauss-Classical summation theorem is shown in equation 6.5, and hypogeometric forms of some elementary functions are shown in equation 6.7 and 6.8. Now main integral is integral first, which is minus pi by 2 to plus pi by 2 sine t whole की power alpha cos t whole की power beta e raised to power iota gamma t dt is equal to pi e की power iota pi by 2 gamma upon plus beta 2 raised to power alpha plus beta gamma 2 plus alpha plus beta plus gamma upon 2 gamma 2 minus alpha plus beta minus gamma upon 2 2f1 minus alpha minus beta minus gamma upon 2, 2 minus alpha plus beta minus gamma upon 2 minus 1, where real part of alpha greater than minus 1, real part of beta greater than minus 1, real part of alpha plus beta greater than minus 2, and 2 minus alpha minus beta minus gamma upon 2 belongs to complex number excluding z0 negative. By equating real and imaginary parts of equation 7.1, we get equation 7.2 and 7.3. Integral 4, which is minus pi by 2 to pi sine of t whole की power alpha cos of t whole की power beta t की power iota gamma t dt, and its right hand side is shown in equation 8.1. By equating real and imaginary parts of equation 8.1, we get equation 8. We get integral 8.2 and 9.1. Integral 7, which is 0 to pi by 2 sine of t whole की power alpha cos of t whole की power beta e raised to power iota gamma t dt. This right hand side is shown in the equation 9.2. By equating real and imaginary parts of integral 7, we get integral 8 and integral 9. This is the proof of the integral 7.1. Here we have used hyperbolic formulas of sine t and cos t, and after further simplification, we used Gauss-Classical summation theorem in equation 11.1. After further simplification, we get the required result. Other associated integrals as special cases, these integrals have been evaluated from the main integrals. In equation 7.1, put beta is equal to 0, we get integral 12.1, where real part of alpha greater than minus 1. In equation 7.2 and 7.3, put beta is equal to 0, we get integral 12.2 and 12.3. In equation 7.1, put alpha is equal to 0, we get Grobner half beta integral shown in equation 12.4. In equation 7.2 and 7.3, put alpha is equal to 0, we get Nielsen integral shown in equation 12.5 and 12.6. In equation 8.1, put beta is equal to 0, we get integral 13.1. In equation 8.2 and 9.1, put beta is equal to 0, we get integral shown in equation 13.2 and 13.3. In equation 8.1, put alpha is equal to 0, we get integral shown in equation 14.1. In equation 8.2 and 9.1, put alpha is equal to 0, we get integral shown in equation 14.2 and 14.3. In equation 9.2, put beta is equal to 0, we get integral shown in 15.1. In equations 10.1 and 10.2, put beta is equal to 0, we get integrals shown in equation 15.2 and 15.3. In equation 9.2, put alpha is equal to 0, we get integral shown in equation 16.1. In equation 10.1 and 10.2, put alpha is equal to 0, we get Grobner half beta integral shown in equation 16.2 and 16.3. We have also obtained applications in Weber and Anger type functions. The Weber the Weber and Anger functions are defined by formulas shown in equation 17.1 and 17.2. We have made integrals parallel to Weber function and parallel to Anger function. The integrals parallel to Weber functions are shown in equation 17.3 and 17.4. Integrals parallel to Anger function are shown in equation 18.1 and 18.2. Conclusion. In this paper, we have evaluated Grobner-Hofreiter type integrals and some applications in Weber-Anger type functions by using hypergeometric approach. Either is beta function and Gauss-Classical summation theorem. We conclude this paper with these words that certain Grobner-Hofreiter type integrals and other different integrals which may be different from those presented here can also be evaluated in a similar way other than Cauchy residual theorem. Moreover, the mentioned integrals is supposed to find various applications in applied mathematics and theory of probability. We may consider the definite integrals whose limit varies from 0 to pi 0 to 3 pi by 2 and 0 to 2 pi c Quraishi etc. all into them. These are the references. Thank you.
May I call upon Mr. Tafajul Rahman Shah, research scholar, Jamia Millia Islamia, Central University, New Delhi, to kindly present the paper. Kindly, please, sir.
Good day to everyone. I am Tafuzur Rahman Shah, a research scholar of Jamia Millia Islamia under the supervision of Professor M.I. Quraishi. I am here to present the presentation with entitled Certain Generating Relations Associated with the Family of Bessel Functions and Multiple Hypergeometric Functions. This is the outline of this presentation. In this paper, we have obtained Lorentz type hypergeometric generating relations of certain mixed spatial functions related to the Bessel function using series rearrangement technique. Also, we have shown some generative functions for Apple's function, Lorentz law function, and multiple hypergeometric functions of Campy-Difflet. And now, in this paper, we use the following standard notation. First, the Camber symbol alpha of p, we define it as gamma of alpha plus p divided by gamma of alpha p. This alpha of p equals 1 if p equals 0 and alpha is a complex number excluding 0. This is also equal to alpha into alpha plus 1, alpha plus 2 up to dash alpha plus n minus 1. This condition is hold when p equal to n belongs to natural number and alpha is a complex number excluding are not negative. This alpha p equal to minus raised power minus 1 raised power n k of k factorial divided by k minus 1 at n factorial. When alpha is negative times k, p equal to n and n of n comma k belongs to n naught, such that k is greater or equal to n and n is greater or equal to 0. And this alpha p is also equal to 0 if alpha is equal to negative times k, p equal to n and n comma k belongs to n naught and n is greater than k. This is also equal to minus 1 raised power n divided by 1 minus alpha of n if p equal to minus times n, n belongs to natural number, alpha not equal to 0, plus minus 1, plus minus 2, and so on. And it is conventionally understood that 0 of 0 equals 1. Now, multiple hypergeometric functions of Campy-Difflet. Here, alpha of a, this denotes that LA has capital A terms, and B I raised for I has B capital B I terms. So this is above equation 2.1. This is a multiple hypergeometric series in a special case of generalized Lorentz series in several variables, and this is introduced by Srivastava and those in 1969. Suppose we have this equation. This converges when these three conditions will satisfy. Now some well-known results. apple function of two variables. First, this is the apple function of first kind, this is the apple function of second kind, this is the apple function of third kind, and this is apple function of fourth kind. Now the first kind apple function of first kind holds this when this condition is satisfied, that is maximum mod of x mod of y less than 1. And for second kind apple function of second kind, mod of x plus mod of y less than 1. And for third kind, maximum of mod of x mod of y less than 1. And for fourth kind, under root of mod of x plus under root of mod of y less than 1. This is the decomposition of bilateral series. And this is the Euler formula 5.3 and 5.4. And this 5.5 is the variable Hermite Bessel function associated with the Bell type polynomial of three variables. Now coming to the main results which I have solved in my paper, generative relations. These are some generative relations. This holds when t is not equal to 0. When t is not equal to 0, these all the generative relations, these all the results hold as true. So this is the first general. These are general relations. First, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, and last is 9.1. Now we have given the proof of some relations. This is the proof of relation 6.1 and 6.2. From equation 3.4, which is the Lorentz-Sala 3.4 and 5.2, we have expansion of x. We have this equation. After 10, we are discussing 10.1. After some substitution and simplification, we get the equation this. And further, using the Euler formula, that is 5.3, we get the equation in two parts, that is real part and the imaginary part. After equating the real part of equation 10.3, we get this equation 10.4. By simplifying, by substituting some substitution and further simplification, we get the given relation 6.1. Similarly, after taking the imaginary part of equation 10.3 and giving some substitution and applying some substitutions in it and further simplification, we get the relation 6.2. Similarly, we can solve here, we can prove the relation 6.3 and 6.4 in the same manner. Now this is the proof of relation 8.1. We have taken where epsilon is equal to this hypergeometric function. After this hypergeometric function, we have changed this into the summation series. After simplifying this, we are getting the last result. That is the result. There is a hypergeometric form. We get a relation 8.1. Similarly, we get a relation 9.1 in the same way. Now these are special case of these are special cases. In 11 general relation 8.1, if we put a equals b equals 0 and first element of d 1 equal to second element of d, third element of d, and nth element of d equal to 1, and first element of e, second element of e, third element of e up to nth element of e equal to 1. Also first element of d1 equal to d1, second element of d1 equal to d2, third element of d1 equal to d3, and nth element of d1 equal to dn. And similarly, first element of e1 equal to e1, second element of e1 equal to e2, third element of e1 equal to e3, and up to nth element of e1 equal to en. We get the general relation, that is 17.1. Now when we take x3, x4, and up to xn equal to 0 in the above equation 17.1, we can show this equation in the term of Laplace function of second kind. Similarly, in 12th general relation 9.1, if we put a equal to 0, b equal to 1, first element of d equal to 1, second element of d equal to third element of d3, and so on, nth element of d equals 2. And similarly, first element of E1, second element of E, third element of E up to nth element of E equals 0, and first element of D1 equal to D, second element of D1 equal to G2, third element of D1 equal to G3, up to nth element of D1 equal to Dn, and second element of D2, second element of D2 equal to H2, third element of D2 equal to H3, nth element of D2 equal to Hn, B1 equal to B, we get the generative relation, this 18.1. Now, in if we take x3 equal to x4 equal to up to xn equal to 0 in 18.1 equation, we can show this equation in terms of Laplace function of third kind, that is this 18.2. Similarly, again taken the 11th generation 8.1, if we put a equal to 0, b equal to 1, first element of d1, first element of d equal to second element of d is equal to third element of d is equal to nth element of d equal to 1. Similarly, first element of e1 equal to second element of e2 equal to third element of e equal to nth element of E, that's equal to 0, and B1 is equal to B, first element of D1 is equal to D1, second element of D2 is equal to D2, up to nth element of D1 is equal to Dn, we get the general relation 19.1. Now, if we take x3, x4 up to xn equals 0, we get the Laplace function of first kind, that is 19.2. This is the conclusion of this paper. We conclude the present investigation by noting that the Bessel family of Bessel function is introduced in a standard form. The results derived in this paper are quite significant and general in character. More, the application of this paper in a diverse field of mathematics, physical science, statistics, and engineering science. This is the references of my paper. Thank you.
May I now request Ms. Nandini from Shri Vishwakarma Skill University, Haryana to kindly present the paper. Please, Ms. Nandini.
Good morning, everyone. I am Nandika from PG Diploma in Public Health, studying in Sri Vishwakarma Skill University, Haryana. First of all, thank you for giving me the opportunity to represent my presentation on my paper COVID-19 and its implication on air quality index in Palwal and Gurugram using statistical techniques. Now, I would like to start my presentation. My paper is divided into 5 chapters. In the chapter first, Introduction, we have given a slight hint of definitions and some important terms. In chapter second, Literature and Review of Air Quality Index, we have given different formulas given by various scientists in different countries of the world. In chapter third, a brief idea of Mankindal test. In chapter 4, we have demonstrated trend analysis of air quality index in Gurugram and Palwal, which we have collected with the help of internet, that is secondary data. And in the end, results and conclusion recommendations are listed. Let's move on to the introduction. In introduction, we have focused on these 5 topics: literature, review of air quality index, impact of coronavirus on the environment. Second, due to coronavirus, WHO forced Indian government to impose lockdown, which was done on 22nd March of 2020, and we observed a drastic improvement in air quality index. Then we discussed how the climate change decreased the air pollution, then the reason for climate change, what is AQI, and what does it reveal. Let's move on to the objectives. Next slide of my presentation. The objective of my project is to compare the atmospheric pollutant concentration in Gurugram and Palwal during the pre and post lockdown period. Secondly, to identify the integrated air quality due to implementation of lockdown regulation during the lockdown period. Third, to know the level of optimum pollutant concentration in these regions, which may not hamper the development of countries. Fourth, to inform citizens about the associated health impact of decreased air exposure. Let's move on to the next slide. That is scope of work. It includes the review of available AQI, including international practices, to suggest health impact threshold limit for 4 parameters for which short-term inequality standards are prescribed. Develop a uniform AQI considering objectives, health impact, air quality standard existing and future monitoring scenario including parameter matters and frequency of measurement and other relevant aspects. Last, reasons in increment of sulfur dioxide that is SO2 composition during this lockdown in Gurugram and Palwal. Now, that's complete now. Let's move on to the next slide of my presentation that is literature review of air quality index. Here, we have given the definition of AQI, structure of an index, different indices introduced by various authors in different form. In the form of green index that is GI, Fanstock AQI, Ontario API, ORAQI that is Oak Ridge Air Quality Index, Greater Vancouver Air Quality Index that is GVAQI, MURC, Most Undesirable Respirable Containment Index. We also discuss the current status of AQI in India. Now, I would like to discuss materials and methods. Here, in my presentation, India proposed the following system where AQI is equal to the maximum of different pollutant level. In our work, we applied non-parametric tests to calculate the trend linear regression. Here, we calculated the linear regression between days and AQI. Okay, that's complete. Now I would like to discuss results and discussion. In Gurugram, it is observed that the statistically significant decreasing trend before the lockdown, that is -3, 0.826 per day, and increasing trend after lockdown plus 1.6399 was observed with a 95% significance level. Moreover, there is a statistically significant improvement in air quality index during lockdown. Whereas in Palwal, it has been noted down that a statistically significant decreasing trend before the lockdown -3 per day, an increasing trend after lockdown that is plus 0.5147 was observed with a 95% significance level. Moreover, there is a statistically significant improvement in air quality index during the lockdown. Okay, that's complete. Now I would like to change my slide. In Gurugram, the man-Kendall test has been shown statistically significant decreasing trend for 90 days with 95% significance level, whereas in Palwal, the statistically significant increasing trend for 90 days with 95% significance level. It can be seen that most pollutant air quality index is good or satisfactory. It is particulate matter 10 and particulate matter 2.5, which is in a moderately polluted category and majorly affecting AQI. Okay, let's move on to the conclusion and recommendation. The results of the study shows that the Gurugram and Palwal region is statistically significant to climate change. Our study shows a significant decrease of about 1.5 in Gurugram and 1.09 in Palwal through the out 90 days. The analysis of Palwal data shows an interesting observation that is a major pollutant of SO2, that is sulfur dioxide, has increased with 37% than the previous amount. It is important to conserve things such as vegetation, particularly the forest, as these reduce greenhouse gas emissions and influence climate change. Secondly, by generating awareness and capacity building of community towards healthy living conditions by promoting ecosystem sanitation, water, rainwater harvesting, water conservation, recycling, planting many trees and reuse, all these should be done on large scale. Okay, that's it. It was the bring of my end of my presentation. Thank you. Thank you very much for your attention. Have a nice day.
May I also request Mr. Rohit Kumar from Vishwakarma Skill University, Palwal, Haryana, to present the paper. Yes, Mr. Rohit Kumar.
Hello everyone, my name is Rohit Kumar and I have conducted a study with my faculty members Dr. Jayant and Dr. Bhavika over a topic antenatal care and child immunization. A study to analyze the accessibility and utilization status in Palwal, Faridabad and Gurgaon using statistical techniques. and these are the districts of Haryana. We have selected these studies for our project due to the presence of our university's main campus in Palwal and current campus in Gurgaon and Faridabad is the nearby district. We, ha- uh, we have conducted this study with the aim to understand the level of improvement and the growth in the utilization of health services, which are antenatal care visits and immunization among the children aged 9 to 11 months in all these three districts. Uh, there should be there could be a scope for our work, which are review of available statistics of antenatal care visits and immunization, suggest health impact of non-utilization of health services during pregnancy for which health services are prescribed, suggest a qualitative description of health services and associated likely health impact for different health issues. We can also we can also know the status of effect of COVID-19 on the utilization of antenatal care and immunization during the lockdown. In this slide, I, I want to give you an overview of our whole project. As I already told you the aim of our study, which is to understand the level of improvement in the statistics of antenatal care visits and immunization. For our study, we have used health management information system and National Family Health Survey for data. We have searched so many research papers, journals, articles, newspaper, and official websites to collect the required knowledge regarding our project work. We have found many relative research papers and articles mentioned, which we have cited in our paper. Uh, we also know the impact of antenatal care over the immunization and possible ways of awareness and health education. And also, we also discuss in our paper how immunization is cost-effective measure to reduce the disease burden from the society. In the methods, we have performed a non-parametric test because we have a data which does not have a normal distribution. So, to manage the data, we have used Microsoft Excel, and in Microsoft Excel, we have also used a trend line feature to predict the trends in the data for the future and to perform the man candle test, which is a non-parametric test. We have used our program for our study. These are the results of antenatal care visits, which show which shows the relevancy of data with time. There is a quite relevancy in the data for the Gurugram. Either it may be quarterly, yearly, or annually. There is only a second quarter in all the years from 2014 to 20, which does not have any significant results, and the rest of have a quite positive results and have a significant relevancy in our data. On the other hand, when we talk about the Faridabad, it does not show any relevancy of data in quarterly, mainly in the second quarter. On while it shows the relevancy in the data and half yearly or quarterly, except one. But when we conclude the result on yearly basis, then it shows no relevancy in data on the annually basis. And when we comes to the Palwal district, which shows a very less relevance in data among all the three of districts, because Palwal only has quarterly basis, a quite relevance data. When we perform the man candle test, there is only one line which shows a relevancy in data, which is quarter third, and rest of there is no relevancy of data, which is due to the irregularity of services in the Palol district. There is the data result for the fully immunized children 9 to 11 months age. Similar, here the same impact in the services for Gurugram. We have found a quite relevant relevancy in data for the Gurugram for 2014 to 20, and also there is similar results for the Faridabad, which have a quite relevancy in data for Faridabad. But when it comes to the Palwal, it shows only 3 occasions where the data have a relevancy on the quarterly basis, in second and fourth, and in half yearly, then the second half of the year. But when it comes to the annually, it does not show any relevancy in data. Conclusion: we have concluded that from the results, we have concluded that there is a statistically more improvement in the utilization of antenatal care and the immunization in Gurugram and Faridabad. We have concluded this study concluded with a level of significance of 85% due to the error, uh, type 1 error. Moreover, the overall improvement is constant in the main area of all the districts, while the other parts have major peaks which show the regularity in the delivery of services and utilization of services. When we talk about the utilization of services in Gurugram, which have quite relevancy in data due to the proper delivery of services, but still there need but still there need improvement in the delivery of services and the awareness in the rural parts of the Gurugram. And similarly, when we talk about the Faridabad, where there is a quite significant improvement in the results, but there is also need improvement, because there is a one occasion where the data does not show a relevancy on the annually basis, and in one occasion in quarterly basis. So there is also need improvement in the health system, also in the health education and the awareness campaigns. And when you talk about the Palwal, there is much improvement needed. It is a different thing that the overall there is the improvement in all the data, all the statistic data, that it is improved than the previous data. There's an improvement from the previous data, but that is not the up to mark that it could be. So there need much improvement. Also, there is need a health system which not only provide the health services but also provide the health education and tell them about the procedures and provide the health education, and also provide the benefits and their future scope, how they reduce the burden for from individual and from the society. And also we can recommend that there should be a health system which not only provide the health but also promote the health education and spread the awareness on the different occasions in the society.
Thank you very much. I thank each and everyone for presenting the paper. Now we shall move on for interaction. Kindly click the interaction or discussion live in Zoom button just below this, and you will be taken to the Zoom. Chairperson will interact, and the other paper presenters can also clarify their doubts if any, and we as organizers will also announce few things for tomorrow. Thank you very much.